by maintaining equal phase shift. Don't draw plus or minus 90, sir. Leaving 2 poles only. I'll draw plus or minus 90 means wrong. So n poles is divided by n. How many poles are there? 3. So that means plus or minus 60. 1 is plus 60 minus 60, 120. So 60, 120 means 180. So that means one pole moves along 180 degrees. And now come and draw the root locus diagram. This pole arm say left side it will come. Then it occupies 0. It occupies 0 minus 2 when k equal to infinity. When k equal to infinity. That means 1 pole 1 0 completed. 1 pole 1 0 completed. 1 pole 1 0 completed. These 2 poles turn towards the left. These 2 poles turn towards the left and enter at the break point. These 2 poles turn towards the left, enter at the break point. Turn towards the left and enter at the break point. These 2 poles turn towards the left, enter at the break point. This pole also turn towards the left, enter at the break point. Turn towards the left. This pole also turn towards the left, enter at the break point. Enter at the break point. So both the poles turn to, because zeros are in the left hand side, compulsory it has to turn to left only. Zeros in the left, so it's to turn towards the left only. So if it is turned towards the left, then enter. Then one pole moves towards 1 0, another pole moves towards another 0, occupies the 0 when k equal to what? Infinity. So turn towards the left. It occupies 0 when k equal to what? Infinity. When k equal to infinity. That's all. When k equal to infinity. Is it clear, all of you? Is it clear? Right, very good. Next rule. Rule number 7. 7th rule. Intersection point with imaginary axis. Intersection point with imaginary axis. Intersection point with imaginary axis. The intersection point with imaginary axis obtained by RS criteria. The intersection point with imaginary axis is obtained by RH criteria. Step 1. Form characteristic equation. Step 2. Come on, tell. Form characteristic equation. Step 2. Write Routh tabular form. Write Routh tabular form. Step 3. Form find k marginal value. Find k marginal value. Form auxiliary equation. Form auxiliary equation. The roots of auxiliary equations are valid and invalid intersection point with imaginary. Valid and invalid intersection point with imaginary axis. Valid and invalid intersection point with imaginary. For valid intersection point, k marginal positive. For valid, IP means intersection point. For valid intersection point, k marginal. K is positive when k greater than 0. So, for valid intersection point, k marginal should be positive. That's all. RH criteria we knows na. Solve it one problem. Come on, do it one problem. RH criteria we knows na. Find the intersection point with imaginary axis. Find the intersection point with imaginary axis. for g of s h of s equal to k divided by s into s plus 5 into s plus 10. Come on, do it all of you. Then right. Check your side only, Princip Patel. Problem is your side. Voice audible only. All are telling audible only. You are only telling not audible. Priya 750. Das, you did wrong. 48 wrong, check it. 750, Sharma correct. Yes, correct, 750 correct I think. But not K marginal. What I need, intersection point with imaginary I required, intersection point with imaginary you tell. I is plus or minus J. Yes, correct. Root 50, correct. Santosh, very good. So Santosh, I is K marginal 750, right, solution. Characteristic equation. 1 plus g of s h of s equal to 0. So what is the characteristic equation? Tell. 1 plus k by s into s plus 5 into s plus 10 equal to 0. Then characteristic equation is s cube plus 15s square plus 50s plus k equal to 0. Come on, tell. Write the Raute tabular form. S cube, s square, s power 1, s power 0. So here it is 1, alternate 50, here 15, here k, 750 minus k by 15, here k. Now tell, for k marginal s power 0 not consider. So make here equal to 0, marginal stable. That means k marginal is 750. K marginal 750, it is a positive. Our range of k also 0 to infinity. Range of k 0 to infinity, k marginal positive means value. In case k marginal negative, k range is 0 to infinity, invalid. K marginal should be in the given range of k only. In the given range of k only. Okay, na? Right, auxiliary equation. So what is auxiliary equation? Tell, come on. 15s square plus 750 equal to 0. So then 15 5 ja. So 50. So s equal to what? Tell? Plus or minus j root 50. S equal to plus or minus j root. It is a valid intersection point. It is a valid intersection point. Valid intersection point. That's all. Okay, na? Right. Clear na all of you? Right. Next one. Last rule. Rule number 8. Angle of departures and arrivals. Angle of departures and arrivals. Angle of departures and arrivals. So how to find angle of C? First of all, where you have to calculate angle of departure? Tell. Where you have to calculate angle of departure and angle of arrival? See, listen all of you. Anybody can you answer? At complex poles, very good. Complex poles and complex zeros. See what angle of departure means? For example, see, we don't require angle of departure and arrival for the real poles and real zeros. Why we don't require angle of departure and arrival for real poles and real zeros? Anybody? Why we don't need angle of departure arrival for real poles and real zeros? For example, listen all of you. I'll take one pole here. What is angle of departure for this pole? Anybody? This side root locus branch exists. Departure means leaving from the initial position. Departure means leaving from the initial position. Leaving from the initial position. Come on, what is angle of departure of this pole? What is the angle leaving here? Anybody answer? Plus or minus 180 degrees. Very good. Plus or minus 180 degrees. It is 100% correct. I'll put one more pole here at minus 2. So what happened? Tell here root locus branch exists. Here k equal to 0. What is angle of departure of this pole? Anybody? What is angle of departure of pole at minus 2? Angle of departure of pole at minus 2. Anybody? 0, yeah. This side it is moving, na 0. It is 0, yeah, Guruji. Yes or no? It is a 0, Guruji. This side means it is 0 degrees. It is moving towards the right side, na. It is 0 degrees. Left means what? 180 degrees. Yes or no? Yes or no? Is it clear, all of you? Is it 0 degrees? Right. For example, if in case I'll put a 2 poles here, what is angle of departure? Means this side cannot move, this side cannot move. It cannot move this side because no root locus. This side also no root locus. You can say here plus or minus 90 is angle of departure. Whatever it is, the angle of departure arrival we can find it directly for real poles because based on the what real axis root locus branch. Based on real axis root locus branch. For example, I'll put here 0. Come on, tell. What is the angle of arrival? Anybody? What is the angle of arrival? Anybody? What is the angle of arrival? This direction. What is the angle of arrival? Come on. 180 degrees. Angle of arrival 180 degrees. Even departure also 180. Okay, na? Right. So like this. So we don't require any angle of departure arrival for real poles and real zeros. We don't require any angle of departure and arrival for real poles and real zeros. Be remember. Okay, na? For complex pole. For example, I'll represent here complex pole. Now what is angle of departure? Come on. Can you tell directly? Can you tell directly anybody? What is angle of departure? Can you tell directly anybody? Come on, anybody? Can you tell angle of departure? Anybody? Nobody telling. Is it possible to tell directly? 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 Nobody telling. Sharma, Divya, very good, very good. Not possible. That means what we need to calculate. This departure depends on other poles and other zeros. What is angle of departure means? As k increases, the pole leave with some angle. With what angle the pole depart from the initial position? With what angle the pole leaves depart? With respect to 0 degrees. 0 degrees means horizontal line. Right side with respect to this 0 degrees. Parallel to this line. With what angle the pole depart leaves from the initial position? Given by angle of departure. Given by angle of departure. With what angle the pole depart leaves from the initial position? Given by angle of departure. Given by angle of departure. Okay, na? What is angle of arrival? Tell. For example, I'll take here complex zeros. For example, I'll take here complex zeros. So what happens? As k go on increase, the poles will come in some direction. As k go on increase, the poles will come in some direction and occupy the 0. The poles will come some direction and occupy the 0. With what angle? With what angle the pole arrives, terminates, and near the complex 0. Near the complex 0 is called angle of arrival. What is departing pole? What is arriving pole only? 0 is the ending place of the pole. 0 is the ending place of the pole. Okay? Right. Yes, correct. Not the angle of asymptotes. Real axis root locus branch, Sharma. What you understood, man? For real poles, we can say real axis root locus branch will decide the angle of departure. Is it asymptote? Tell. I'll take here one pole, here one pole. What you understood, man? Listening, huh? What is departure of this pole? Is it asymptote? Is it asymptote? Well then, it is moving left. Left means 180. It is moving right. Right means 0 degrees. It is real axis. Root locus branch will decide angle of departure for real poles. Is it clear? Right. Right. Now, write angle of departure definition. With what angle? Angle of departure. With what? It gives that. First one word you write it. Angle of departure calculated is calculated at a complex conjugate poles. At a complex conjugate poles. And angle of arrival is calculated at complex conjugate zeros. So departure is poles, arrival is complex conjugate zeros. Okay, na? Is it clear, all of you? Right. What is angle of departure? Write the definition of angle of departure. It gives that. Now, follow tell. It gives that. It gives that. With what angle the pole depart? It gives that with what angle the pole depart or leaves. Depart or leaves from the initial position. From the initial position. It gives that with what angle the pole depart or leaves from the initial position. From the initial position. Initial position. Okay, na? So what is the formula for pi d? Tell. Pi d equal to 180 plus angle GH. Pi d equal to 180 plus angle GH of S. At a positive imaginary complex pole. Positive imaginary complex. You can find on negative imaginary also, nothing wrong. But if you take positive imaginary, the number of negative terms are less, so that the calculations become easy. That's why I'm taking positive imaginary means this one. We'll calculate here positive imaginary. Here, see my pen cursor. So here we'll calculate positive imaginary means. Okay, na? And at this point it is opposite side. Here plus 45 means here minus 45. That's all. On negative imaginary complex pole, we'll take opposite side. So 180 plus angle GH. One more formula also is there, but I will use this first formula only. One more formula is for R, pi d equal to 180 minus pi. 180 minus pi. Where pi equal to sum of angles contributed by the poles minus sum of angles contributed by the zeros. Where pi equal to sum of angles contributed by the poles minus sum of angles contributed by the zeros. Sum of angles contributed by the poles minus sum of angles contributed by the zeros. But I will use first formula only. Okay, na? Next, angle of arrival. How to calculate? We'll solve the problem. It gives that with what angle? It gives that with what angle the pole. It gives that with what angle the pole arrives. The pole arrives or reaches or ends at a complex zero. Ends at a complex zero. It gives that with what angle the pole arrives, reaches, ends at a complex zero. So what is the formula? Angle of arrival formula. Pi A equal to 180 minus angle GH. Angle of GH of S. At a positive imaginary. At a positive imaginary complex zero. At a positive imaginary complex zero. Okay, na? At a positive imaginary complex zero. Pi A equal to 180 minus angle GH. At a positive imaginary complex zero. Okay, na? R Pi A equal to 180 plus pi, where pi equal to sum of angles contributed by the poles minus sum of angles contributed by the zero. This is the second formula. Tell Divya, what is your doubt?
No doubt.
Huh?
No doubt.
Okay, write the answer. Okay, right, that's all. Note on the problem. Calculate angle of departure. Calculate angle of departure at a complex poles. At a complex poles for G of S, H of S equal to K into S plus to S plus by S square plus 2S plus 2. Come on, do it. Come on, do it, man. Represent the poles and zeros. What is G of S, H of S we taken? K into S plus 2 into S plus 4 divided by S square plus 2S plus 2. ठीक है ना? Right. First represent the poles and zeros in the display. First represent poles and zeros in the display. Right. Now come on, where are the poles? Tell. What is the location of pole? -1 plus r minus j1. -1 plus r minus j1 is the pole location. Zeros is -2. Another 0 is -4. So here k equal to 0. Here k equal to 0. Here k equal to infinity. Here k equal to infinity. Here there exists a root locus branch. Come on, calculate angle of departure now. First angle GH you calculate. Angle GH. Angle of GH of S. At S equal to -1 plus J1. At S equal to -1 plus J1. That equal to angle of K, angle of S plus 2, angle of S plus 4 divided by angle of S plus 1 minus J1, angle of S plus 1 plus J1. ठीक है ना? Now S replaced by -1 J1, come on. That is angle of K into angle of, come on, S replaced by -1 plus J1. -1 plus J1 plus 2. Like -1 plus J1 plus 4 divided by, come on, -1 plus J1. S plus, put it -1 plus J1 plus 1 minus J1. -1 plus J1 plus 1 plus J1 plus J1. Now tell, come on. What is the answer? Tell here. -1 plus 1 cancel, plus J1 minus J1 cancel. -1 plus 1 cancel. Then tell what is the answer? Tell, come on. The answer is angle of K. Angle of what? Tell here. -1 plus 2 means 1. So 1 plus J1 into below here. What is the answer here? Tell. 3 plus J1. 3 plus J1 divided by here angle of 0. Angle of what? J2. Angle of J2. ठीक है ना? Now tell angle of K is 0 degrees plus angle of 1 plus J1 below. Tan inverse of 1 by 1 means 45 degrees plus tan inverse 1 by 3. Tan inverse 1 by 3, 18.43 tan. Tan inverse of imaginary part by real part angle. Angle of 0 is 0 degrees. Angle of J2 is 90 degrees. Angles are added or subtracted? Added and subtracted, we remember. That means what you are getting, tell here. What is the angle? This will become 63, I think. 63.43 positive angle. Plus 63, 45 plus 18, 63.43 minus 90. So that means angle GH equal to, how much you are getting? Minus 26.57 degrees, I think. Angle GH equal to minus 26.57. Now find angle of departure. Direct to 2 marks bit, they used to ask it only angle of departures and breakpoints. Direct to 2 marks bit, they used to ask, many times asked on angle of departures and breakpoints. These two are very important. So be remember. So now tell, Angle of departure phi d equal to 180 plus angle GS. Phi d equal to 180 plus angle GS. So what is the answer? Tell. 180 minus 26.57 degrees. That equal to what is the answer? Tell. Plus 153.43 degrees. So finally, phi d equal to plus or minus here. First sign for positive imaginary, second sign for negative imaginary. Plus or minus 153.43 degrees is the answer. So the angle of departure is plus or minus first sign for positive imaginary, second sign for negative imaginary. Plus or minus 153.43 degrees. Now draw the root locus diagram. That means this pole will depart with the angle of what? 153 degrees. This pole will depart with the angle of 153. This pole will depart with the angle of 153 plus 153. This pole will depart with the angle of minus 153. This pole will depart with the angle of minus 153 degrees. You find the break point in your home dummy procedure. Na? Finding the break point is a dummy procedure. You find it. 2.61 you will get. You check the break point in your home. dk by ds. You will get minus 2.61. Number of asymptotes 0. Angle of asymptotes not required. Nothing is required because 2 poles to 0. Whenever number of poles equal to number of zeros, centroid, angle of asymptotes, so all these are not required. Simply drawing a path. You identify a path from pole to 0 such that root locus diagram should be what? You find out angle tan inverse of imaginary part by real part. Use the calculator. Right. How to get the angle? Tan inverse of imaginary part by real part. Use the calculator. Get the answer. Right. So it will depart, enter at the break point. It will depart, enter at the break point. It depart and enter at the break point. Okay, na? The depart, enter at the break point. This pole also depart. It enter at the break point. Depart. Enter at the break point. And occupies the 0. This is called root locus diagram. This is a root locus diagram. That's that. Is it clear, all of you? Is it clear, all of you? Right. Next problem. One more problem is solve it. See, for each and every rule, 2-3 problems we are solving. Either you are observing or not. Find 99% of the questions. If you are perfect in rules, or whatever we discussed up to 8 rules, angle condition, magnitude condition, up to this, whatever the things we discussed, if you are perfect, more than 95% of the problems you can solve, no doubt. Remain 5% just they use tasks, 1% only, strictly speak. 1% only they use tasks little bit complex. So if you perfect up to this, no doubt you can solve more than 90%, 95% of the problems. So practice the rules. Individual rules are more important. Find angle of arrival to the given system. Same thing I am taking a. Same thing here. Reverse I will take, that's all. Numerator, denominator I will interchange. K into S square. Now complex zeros I will take. Come on, do it all of you. Calculate angle of arrival. Represent poles and zeros in the explain. This is complex zero. Poles were at -2. Another pole -4. Here root locus branch. Here K infinity. So this is positive imaginary. Come on, calculator. Angle GH of S at S equal to where? Positive imaginary means -1 plus J1. Come on. Angle of K. Angle of S plus 1 minus J1. Angle of S plus 1 plus J1. Divided by angle of S plus 2, angle of S plus 4. So suppose check it once. Is it wrong? Now come on, get the answer. Angle of K, angle of -1 plus J1 plus 1 minus J1, angle of -1 plus J1 plus 1 plus J1, angle of -1 plus J1 plus 2, angle of -1 plus J1 plus 4. Now come on, tell the answer. -1 plus 1, J1 cancel, 1 1 cancel. Now come on, tell man. Angle of K, angle of 0, angle of J2, angle of here what happened? 1 plus J1, angle of what? 3 plus J1. Come on, get the answer. Use the calculator. Tan inverse of imaginary part by real part. Angle of K 0 degrees, angle of 0 0 degrees, angle of J2 90 degrees, imaginary positive imaginary 90. Angle of 1 plus J1, tan inverse of imaginary part by real part. Tan inverse 1 by 1, 45 degrees. Tan inverse 1 by 3, imaginary by real. Use it calculator. 14.83. Come on, get the answer. 90 minus 45 degrees minus, when you come to the numerator, opposite sign. Opposite sign. So, plus 26.57 degrees you will get. Then, what is the formula for angle of pi? Angle of arrival? 180 minus angle GH. 180 minus angle GH. The 180 minus 26.57. That equal to plus 153.43 degrees. Plus 153.43 degrees. Then pi A equal to plus or minus 153.43 degrees. ठीक है ना? So that means what? Angle of departure equal to angle of arrival. Angle of departure equal to angle of arrival. Whenever all the poles and zeros are interchanged, the angle of departure become angle of arrival. Here what happened? I put the pole positions here 0, 0 positions I put the poles. That's why the same answer you will get. Here even break point to find it. To find break point in your home, minus 2.61 only. Break point location also not changing. Whenever all the poles, all the zeros are interchanged in the transfer function, the angle of departure equal to angle of arrival. The break point position also not going to be changed. Now as K increases, both the poles move in opposite direction. Both will move in opposite direction, collide. Then direction is opposite. Now compared to the previous case, now the direction opposite, but the shape of the plot also is same. What is angle of arrival here? 153 only, plus 153, plus 153. Here minus 153. Angle of arrival is here, minus 153, 153 degrees, minus 153. Here plus 153. So it moves and then upwards. Like. So direction is opposite here. Direction is opposite. Remain, everything is same. Direction opposite. So this is shape of the plot also same. Okay, na? Is it clear all of you? Right. What is the final conclusion? Whenever all the poles and zeros are interchanged, is it clear all of you? Right. Whenever all the poles and zeros are interchanged, in the transfer function, then angle of departure equal to angle of arrival. Angle of arrival. Breakpoints are not changes. Shape of the plot is same. But the direction changes. Okay, na? But the direction is changes. That's all. So with this, all the rules are completed. Now we'll solve some problems. Right, solution. Not on the problem. So all of you keep all the 8 rules in the mind. Okay, na? Right. Draw the root locus. And discuss the stability. So the given system. G of S, H of S equal to K by S into S plus 2. Come on, do it. Come on. Write the steps, come on. Or 3 steps and step 1. What you have to do? Step 1. Identify real axis, root locus, branches and breakpoint. Identify real axis, root locus, branches and breakpoint. Identify real axis, root locus, branches and breakpoint. Step 2. Find angle of asymptotes and centroid. Find angle of asymptotes and centroid. If required, find angle of departure and arrival. Last step. Vary the K value. Vary K value from 0 to infinity. Identify the path. Vary the K value from 0 to infinity and identify the path. And identify the path. And identify the path from pole to 0. From pole to 0. Vary the K value from 0 to infinity and identify the path from pole to 0 such that RLT should be such that 1 minute. Such that RLD in the root locus diagram should be symmetrical about real axis. Symmetrical about, read all the statement, all of you. Symmetrical about real axis and all the poles should reach the zeros. And all the poles should reach the zeros. Should reach the zeros. All the poles should reach the zeros. Okay, na? Right, that's all. And now come on, do it. Follow these 3 steps. First to find, identify root locus, branches and breakpoint. Next, angle of asymptote, centroid. The complex poles are there. Angle of departure and arrival. Come on, draw it. Do it. Cheyala meeru. Come on, man. Come on. Come on, do it. First represent poles in S plane. One pole at origin. One pole at -2. Here root locus branch exists. Come on. Find the breakpoint, all of you. Find the breakpoint. Already we solved this problem. Breakpoint. d by ds of 1 by s square plus 2s equal to 0. U dash means 0 minus u into v dash. 2s plus 2 equal to 0. Come on, s equal to -1. S equal to -1. Is a valid breakpoint or invalid breakpoint? Is a valid breakpoint. Is a valid breakpoint. So -1 is a valid breakpoint. Right, next, second step. Come on, angle of asymptotes and centroid. Kaniyala. Come on, do it, all of you. Angle of asymptotes and centroid. 90 to 70, very good. Centroid -1, very good. Number of asymptotes. N equal to 2 because P greater than Z. Number of branches 2. Number of asymptotes. N equal to P minus Z. 2 minus 0 becomes 2. angle of asymptotes theta equal to 180 by P minus Z. P minus Z is 2. So 180 by 2 is 90. 180 by 2 is 90. Multiply with odd number. 180 by 2 is 90. Multiply with odd number. Into 3 means 270 degrees. 90 and 270. Very good. Next centroid. Sum of real part of poles. Minus 2 comma minus 2 or minus 0. There is no more poles na. Sum of real part of poles is minus 2. No zeros. Divided by 2. Centroid is minus 1. No angle of departure, no angle of arrival. That's all. Now represent all these things in the diagram and draw the root locus diagram. Come on. Draw the RLD now. Come on. One pole at origin. S equal to 0, K equal to 0. One more pole at minus 2. K equal to 0. Here there exists here root locus branch. Here there exists here root locus branch. Break point is minus 1. Centroid minus 1. Number of asymptotes 90. 90 means along this. Na? Along 90 draw it. Along 90 and 270. So one asymptote along 90. Along 90 there is a 0. Where K equal to infinity. Along 270 also there is a 0. Where K equal to infinity. Where K equal to infinity. Right, where K equal to infinity. Now tell, as K increases, come on draw that. This is the what? All the points I represented. Whatever I got it, all the points I represented in the diagram. Now you have to vary K from 0 to infinity and you have to identify the path. Come on tell, as K increases, what happens? The pole cannot move to right here. Here also it cannot move to left. As K increase, this will go on, moves to the left only. This is also go on, moves towards the, this moves right, this moves left. Both are moving in equal in opposite direction. Both will collide. Both will collide. Once it collides, it leaves with plus or minus 90. It leaves with plus or minus 90. One pole leaves with plus 90. Another pole leaves with what? Minus 90. One pole leaves with plus 90. Another pole leaves with minus 90. Then what happens? It will move along the asymptotes and it occupies the zeros. Along the asymptotes, it occupies the zeros. This pole also move along this asymptotes, occupies the zeros. Occupies the zeros. That's all. Occupies the zeros. This is called root locus diagram. Okay, na? Right. Root locus easy only. Once rules are in the mind, it is easy. Then what? When it is stable, stability now. When it is stable. Come on, tell man, when it is stable. When K equal to 0, one pole at origin, one pole at minus 2. Is it stable, anybody? When K equal to 0, one pole at origin, one pole at minus 2. Is it stable, anybody? Stable or marginal stable? Pole at origin stable, hai? There may be 1000 poles left. One pole at origin. What is the system, anybody? One way it is marginal stable. One way it is marginal stable, but it never be stable. Even we don't consider the condition for marginal stability also. In the root locus, marginal stability they consider like this imaginary poles. Plus or minus j omega poles consider for marginal stability. But still, it is just stable, means marginal stable, no doubt. So whatever it is, we don't consider K equal to 0 for stability. We don't consider K equal to 0 for stability. K slightly increased, it come to left. This is also slightly moving right. Stable or unstable, anybody? K greater than 0, stable or unstable, anybody? K greater than 0 means one pole slightly coming left. Another pole also already in the left. Is it stable or unstable? 100% stable. Still K increase, both are left stable. Still K increase, both are left stable. Still K increase, both are left stable. Still K increase, it collide and leave stable. Still K increase, collide, stable. Still K increase, stable. Still K increase. Up to what stable? Infinity. Yes or no? The value of K for which the root locus branches lies in the left hand. For what value of K root locus branches lies in the left? For that values of K, the system is stable. Here K greater than 0, complete root locus branch lies in the left only. That's why it is stable. That means I can write simply K greater than 0, the closed loop system is stable. We are finding closed loop stability and not GH stability. When K greater than 0, the closed loop system is stable. The closed loop system is stable. We are finding closed loop pulse path. It is not a open loop pulse path. It is a closed loop pulse path. It is a closed loop pulse path. It is not a open loop pulse path. So for all the values of K greater than 0, so this particular system is going to be what? Stable. Is it clear, all of you? Right, next one. Clear na? Right, very good. Next, what are the different natures the system is having? Anybody? What are the different natures the system is having? What are the different natures the system is having? Natures means undamped, underdamped, critical damped, overdamped natures. Natures of the system. See, whenever any two poles lies in the left hand side, whenever two poles lies in the left of the S-plane on the real axis, different location. What is the nature? Anybody? Whenever any two poles lies in the left hand side of different location, then the nature is nature. Yeah, it is overdamped nature, Guruji. Overdamped. Overdamped nature. Theta is greater than 1. Yes or no? Whenever any two poles lies in the left hand side, which are repeated. What is the nature? Tell. Critical damped. Critical damped. Theta equal to 1. Whenever any two poles lies in the left hand side, which are complex conjugate. Then it is what? Underdamped. Theta greater than 0, less than 1. Whenever the poles lies on imaginary axis, then we can say undamped. Theta equal to 0. I already discussed all these things in the what? Time domain analysis. Yes or no? Now tell, what are the different natures this system is having? Tell, come on. When k slightly greater than 0, come on, what is the nature? Come on, tell. When k slightly greater than 0, two poles on the negative real axis, different location. What is the nature? Anybody? What is the nature? Overdamped. Very good. Still increase, still overdamped, still increase, still overdamped, still increase, overdamped. Up to meet this point, means this total range is over. One minute I will copy this because I need this diagram. Right. So here up to this is overdamped. So theta what? Greater than 1. What is the response for overdamped? Tell. Overdamped response, remember, it rises sharply. It rises sharply, but decays exponentially. It rises sharply and decays exponentially. So when you meet at particular point, then what happens? System is critical damped. When meet at a particular point, the system is what? Critical damped. What is theta tell here? 1. Theta equal to 1. What is the nature of critical damped system? It increases like ramp and decay. This is the critical damped nature. Remember that? So critical damped nature like this. This is critical damped. Still k increase, what happened? Tell. Listen carefully, this is very important. Both the poles leaves and become complex conjugate. This total, what is the nature? Anybody? This total nature, what is it? What is the nature? Anybody? Come on, underdamped. Theta is greater than 0, less than 1. What is the nature of underdamped system? Decreasing amplitude oscillation. This is for underdamped. That means this particular system having the what? Overdamped, critical damped and underdamped nature, but not undamped. Yes or no? This particular system having, what are the different natures having? Tell. I'll copy here. First one thing I'll do. Right. So this particular system having the what? Overdamped, critical damped, underdamped, 3 nature, but not undamped. It is not having undamped nature. Now find the k values for different natures of the system. Come on, what are the different natures it is having? Find the k values for different natures of the system. Come on, listen. So the above system having, here I'll write. The above system The above system is having under damped, critical damped, under damped, critical damped, and over damped natures. Over damped natures, but not undamped. Okay. To find K values for different natures of the system, for different nature of the system, to find K values for different natures of the system, we require to find K value at the breakpoint. K value at the breakpoint. How to find K value at breakpoint? And breakpoint means it is unroot locus branch. Breakpoint means it is unroot locus branch. No need to check the angle condition. How to find K value at the breakpoint? By using magnitude condition or product of length. I told it already. How to find K value? I told na product of length. Here you can use the product of length. So come on, find here K value. This is the breakpoint. What is the K value? Tell here anybody. Use the product of length. Come on. What is the K value? Anybody? One is magnitude condition. Second one product of length. K is 1 here. The distance from this point here. What is the distance? Size 0. This is -1. What is the distance? 1 unit. So 1 into point to pole. K equal to distance from point to pole. Point to pole is 1. Again, this point to pole is 1. 1 into 1. There is no zeros. You have to check infinite zeros, not infinite. That means 1. So K equal to 1. The K value at the breakpoint equal to 1. The K value at the breakpoint equal to 1. Product of length, use it. Point here 1 into 1. So 1 into 1 divided by no zeros, 1. So that means 1. So K equal to 1. Now tell what is the range of K for overdamp? Here 0, here 1, 0, 1. What is the range of K for overdamp? Anybody? Range of K for overdamp? Anybody? Range of K for overdamp? Range of K for overdamp? Overdamp I am asking. 0 to here 0 kada, here K 0, here K 1. So what is the range of K? 0. K greater than 0 and less than 1 for overdamped system. K greater than 0, less than 1. Overdamped. Here to here is overdamped. This total overdamped only. OD. OD means overdamped. This is also overdamped. So that means 0 to 1 overdamped system. Next tell when it is critical damp. When you meet at a particular point, then it is called critical damp. When you meet a particular point, what is the K value for critical damp? Anybody? K value for critical damp 1. Very good. Because break point is critical damp only. K equal to 1 critical damp. Next, when it is for underdamped, here to infinity. This point to infinity is underdamped. What is the range of K for underdamped? Anybody? K greater than 1. Here 1 now. 1 to infinity. K greater than 1. So underdamped na complex conjugate poles means underdamped. So underdamped system. That's all. It is not a open loop pulse path. It is a closed loop pulse path. It is a closed loop pulse path. Root locus diagram gives closed loop pulse path. RLD gives closed loop pulse path. If you have any doubt, you write the characteristic equation, go on, substitute K value and check the path. What is the characteristic equation? Tell command. 1 plus GH0. How much? Tell command. What is the characteristic equation? S square plus 2S plus K equal to 0. Yes or no? K0. Where is the closed loop pulse? Tell. K0 means what? S square plus 2S equal to 0. Where is the closed loop pulse? Tell. S equal to 0 comma minus 2. Next, K equal to 1. Where should be the poles? Tell. 2 poles at minus 1. It should be repeated. Come and check it. K equal to 1. What is the characteristic equation? S square plus 2S plus 1 equal to 0. And what we are getting? Tell. S plus 1 whole square equal to 0. That means what we are getting? Tell. S equal to minus 1 comma minus 1. Is there or not? At K equal to 1, 2 poles repeated. Critical damped. Yes or no? K greater than 1 you take. If I take K greater than 1, for example 2, what should be the poles? Tell command. K greater than 1. What should be the poles? Tell command. K greater than 1 means system is underdamped. The pole should be what? Complex conjugate. Where the real part should be minus 1, imaginary may be any value, imaginary any value. For example, K2, what is the characteristic equation? S square plus 2S plus 2, 0. What are the poles? Minus 1 plus R minus J1, complex conjugate. Complex conjugate means underdamped. You take K equal to 100 also underdamped only. What is the characteristic equation? S square plus 2S plus 100 equal to 0. What is S? Tell. minus 1. Real part minus 1 and you take any value of k. Real part minus 1 plus or minus j root 99. That means what happened? What happened? It is a which path? Closed loop pulse path or open loop pulse path? Root locus gives open loop pulse path or closed loop? Yeah? Come on. Closed loop pulse path. Right. Is it clear all of you? Any doubt you can raise hand. Is it clear all of you? If you have a doubt, make it clear yourself. Come on, man. Clear, na? Understood, na, all of you? Mahalakshmi. Right, very good. So, like this, they used to ask what is the K value for underdamped, undamped, overdamped. What is the K value for non-oscillatory? Anybody? For non-oscillatory, what is the K value? Non-oscillatory. Anybody? K value for non-oscillatory. Anybody? K value for non-oscillatory. Come on, man. Come on, jaldi, jaldi. K value for non-oscillatory. Anybody? Non-oscillatory systems are nothing but critical damped and overdamped. Yeah? So non-oscillatory means K should be equal to, even equal to also non-oscillatory only. Greater than or equal. It may be marginal stable, I don't want. But here like a step signal you will get non-oscillatory. And less than or equal to what? 1. Here 1 na? 1. So non-oscillatory. Is it clear? Is it clear all of you? Is it clear? Right, Dhruva, what you are doing, man? Is it clear? Any doubt? Dhruva Sharma, understood? Here, what is the answer? What is the non-oscillatory? Raise hand. Raise hand. What are the non-oscillatory systems? Tell. Non-oscillatory system.
Critical and current.
What is the critical means real axis, na?
Yes, sir.
Also real axis, na? So here, what is K?
Less than 1 and greater than. Okay, sir, got it.
Got it,
Yes, sir.
Right. That's all. Next. Here, product of length, Santosh already discussed. We solved problems also. Here to here, what is the length? 1 unit. Here to here, 1 unit. So 1 unit product of length from point to pole. 1 into 1. 1 into 1 divided by, no zeros mean divided by 1. Santosh, is it clear? Raise hand, what is your doubt? Jaldi, jaldi, don't waste my time. Right. Any doubt is there? Jaldi raise hand and then get it clarified. Right, this is okay. Next one. So 2 minutes, another 2 minutes, then we'll take the break. So one more question what they used to ask is, they'll give like this root locus diagram. Examiner, they'll give like this root locus diagram. And they'll ask a question like this. Find the K value. Find the K value to get the damping ratio to operate the system. Find the K value to operate the system with a damping ratio of 0.707 or some angle they'll ask. Find the K value to operate the system with a damping ratio of 0.707. Like this bits they are asking for objective. Listen all of you. Listen by if you listen, then only will get it. Listen. So that means he will give the diagram. He will give the diagram to the given diagram. Okay? To the given system. He will give the diagram. Okay? Find the K value to operate the system with a damping ratio of 0.707 to the given system. To the given system. Shown in figure. So like this they'll ask. So that means we want theta how much test? 0.707. What is the transfer function test? One pole at origin, one pole at -2. That's all. That means K by S into S plus 2. From root locus diagram we can write GH. From root locus diagram we can write GH. Now what you have to do? What is the formula? With angle theta equal to cos theta. Remember that? Find the theta value. Theta equal to cos inverse theta. I will give the break. So that means what is the angle tell? Theta equal to cos inverse of theta. Theta is what? 0.707. So that means 1 by root 2. So what is the angle tell? 45 degrees. The angle becomes 45 degrees. Is it clear up to this? Is it clear up to this? Very good. Now you draw a line with the angle of 45 degrees. You draw a line with the angle of 45 degrees, sir. You draw a line with the angle of 45 degrees. So you draw a line with the angle of what? 45 degrees. Okay, na? So draw a line. So I'll draw a line like this. Okay, it is a somewhere it is intersect. Na, here you have to find the k value. Here you have to find the k value. Okay, na? You need to find the k value here. Okay, you have to find k value here. So this is angle of what? 45 degrees. This is the angle of 45 degrees. This is the angle of 45 degrees. So then it is in here you have to find k. Now you try to find the length. Length you have to find. So what is this length tell? Here to here length is 1. Even here to here length is 1 because this is minus 1 na? 1 to 0 length 1. 1 to 0 length 1. What is this angle? 45 degrees. 45 degrees means what is this length? Anybody? What is this length? Anybody? For example, I'll take this is y. Y I will take. What is y I have to find? So follow tan 45 equal to how much tell man? Tan 45, tan theta equal to what? Y by x. Tan 45 equal to y by x or tan theta. Tan theta equal to y by x. Y by x. What is theta? 45. So tan 45 degrees equal to y. What is x tell? 1. Then find y. Y equal to what? 1. That means this equal to 1. This also 1. Now find this length. This is 1. This is 1. What is this diagonal length? Root of a square plus b square. That means what is this length? Root 2. Again you find this length also. You have to find this length also. You find this length. What is this length? Tell, come on. What is this length? Come on. So this is 1, this is 1. So root of 1 square plus 1 square. That means root 2. Now find the k value. K equal to product of length. Point to pole. What is the length, man? Root 2 into point to pole. What is the length, man? Root 2. Divided by point to 0. There is no point at 0. So divided by 1. That means what is the answer? Tell. K equal to how much? 2. K equal to 2. So if I operate k equal to 2, the given system is going to be operated with a damping ratio of 0.707. Okay, na? Okay, na? All of you clear? Na? If I select k equal to 2, the system is going to be operated with a damping ratio of 0.707. Is it clear? Very good. Sorry. So this is called a complete analysis of the root locus. So when you are drawing the root locus, so this is the complete analysis, finding the stability, nature, selecting the k value to operate at the desired response. To operate at the desired response. Okay, na? This is a complete analysis. I don't solve for all the problems like this complete. So only 1 or 2 problems I'll solve. Remain problems you have to do by yourself. Okay, na? Sorry, take the break. Half an hour break you take. After the break I'll continue. Okay? Next problem. Repeat above problem. Come on, do it all of you. Come on, do it. Look at the poles in the plane. Find the break point. Identify real axis, root locus branches. Come on, this is real axis, root locus. Find the break point, all of you. Find the break point, all of you. d by ds of 1 by s cube plus 2s square plus 2s. U dash means 0. U into V dash means, what is V dash? 3s square plus 4s plus 2. Find the roots, you will get the break points. Come on. Minus 0.6 plus or minus j 0.4 you will get. Is it correct? Check it, all of you. Is it correct? Right. But it is invalid break pointer. Invalid. Whenever complex break point you are getting, whenever you are getting complex break point, then you need to identify either it is valid or invalid. How to identify means, listen, how to identify means, mean, and all of you. You need to identify either it is valid or invalid. How to identify either valid or invalid means, listen, all of you. The real part of the complex pole, whatever is there, this real part should be equal to real part of complex break pointer. For valid complex break point, the real part of complex pole, the real part of complex pole should be equal to real part of complex break point. For valid break point, the real part of complex pole, the real part of complex pole should be equal to real part of complex break point. Then only it is valid. Then only it is valid. Okay, na? What is the real part of complex break point here? Tell. What is the real part of complex pole? Anybody? What is the real part of complex pole? Minus 1. Minus 1. What is the real part of complex break point? What is the real part of complex break point? Minus 0.6. Is it equal? Not equal. So invalid break point. Invalid break point. Clear all of you? Is it clear all of you? In case here minus 1 is there, it is valid, otherwise invalid. Right. Next to find the number of asymptotes, angle of asymptotes, centroid. Come on, do it, all of you. Number of asymptotes. N equal to P minus J. Angle of asymptotes. 180 plus or minus 180. 180 by P minus Z. P minus Z is 3. 60. Multiply with odd number. Multiply with odd number. 60 into 3, 180 degrees. 60 into 5, 300 degrees. 60 into 1, 60 into 3, 60 into 5. Next, find the centroid. Find the centroid. Sum of real part of pole. What is the real part of pole? Minus 1 for this, minus 1 for this. So minus 1, minus 1. Minus of 0. Divided by P minus Z. P minus Z is 3. Minus 0.66 is the centroid. Centroid is minus 0.66. Next tell. Next, what you have to find? Is it sufficient or any more thing we have to find? It is a complex pole, so angle of departure you have to find. Find angle of departure, all of you. It is a complex pole, so angle of departure you find. Calculate angle of departure, all of you. Angle of G of S, S of S. What is a complex pole location? Minus 1 plus J1. At S equal to minus 1 plus J1. Is equal to angle of K by angle of S. Angle of S plus 1 minus J1. Angle of S plus 1 plus J1. Come on, get the answer. Angle of K by angle of S. Minus 1 plus J1. Angle of here minus 1 plus J1. Plus 1 minus J1. Angle of minus 1 plus J1. Plus 1 plus J1. Now come on, get the answer. 1 J1 cancel. Here 1 cancel. So angle of K by angle of minus 1 plus J1. Angle of 0, angle of J2. So what is the answer, anybody? Angle of K 0 divided by what is the angle of minus 1 plus J1, anybody? Angle of minus 1 plus J1. 135 as Santosh. For writing minus 45, I told it. It is a second coordinate. Negative, real, positive, imaginary. What is the angle? Tell. Here to here 180. But it is less than 180. So theta. That means what? What is the angle? 180 minus theta. I told already. 180 minus theta means tan inverse of. 180 minus tan inverse of. Imaginary part by real part. Already I told, yeah. Come on, tell. 180 minus tan inverse of. What is imaginary part? 1. Real part 1. This is for yes. Minus. This is for what? This is for minus 1 plus J1 plus angle of 0, 0 degrees. Angle of J2, 90 degrees. Come on, tell the answer. Tell Tushar, what is your doubt? Kanveer. Tushar, Kanveer, any doubt? Tell man. Any doubt? Jaldi aaya.
No doubt, sir.
Okay, right. Write the answer. Come on, now get the answer. This is 135. 0 degrees by 135 plus 0 plus 90. How much you are getting? Minus 225 degrees. Then angle of departure pi d equal to 180 minus angle GH, 225 degrees. So minus 45 degrees. So then what is the formula? Tell. Pi d equal to 180 plus what I will get? Already written now. So pi d equal to what is the answer? Tell. Minus r plus 45. This is 180 plus angle GH now. Angle of departure is minus r plus 45 degrees. Okay, na? Right. Next one. Now draw the diagram. Now we calculate all the points. Now draw the diagram. Come on, jaldi, jaldi. Draw the diagram, all of you. Represent the poles. Represent the complex poles. minus 1. Come on. Here root locus branches exist. Represent the no break point. Next, what you have to represent? Centroid. What is the centroid? You got it? Centroid is minus 0.66. Here, centroid. Centroid is minus 0.66. Consider it here. Draw the angle of asymptotes. One asymptote is 60 degrees. Along 60, there exists a root locus branch. Along 60, there exists a one root locus branch, where k equal to infinity. Along 180, 10, where k equal to infinity. Along 300, one root locus branch. So now count it, there are 3 poles and 3 zeros. There are 3 poles and 3 zeros. Now draw the root locus diagram. Come on, all of you. What is the angle of departure? You got tell. Angle of departure is minus 45. So draw like this, minus 45. Here angle of departure you got it what? Plus 45. Intersection point with imaginary, find it, we didn't find it, forget it. Find the intersection point with imaginary RH criteria. Intersection point with imaginary RH criteria, find man. Find here. Intersection point with imaginary, shortcut to use it. Intersection point with imaginary. IP means intersection point with imaginary. Come on, tell the answer, man. So what is the characteristic equation? SQ plus 2s square plus 2s plus k. Internal product 4. External product also 4. So that means k marginal is 4. Next one, tell. Frequency of oscillation root 2 na. So intersection point is plus or minus, you find it. You know na s equal to plus or minus j root 2. Intersection point is plus or minus j root 2. Check it with RH criteria. RH criteria, you know na RH criteria. Okay na, intersection point is plus or minus j root 2. Use RH criteria and get it. Okay. So that means intersection point is plus j. Is plus j root is below this line or above this line? Is it below this line or above this line? That is the problem. Below na above na ya? So to identify that, you have to find this point. What is this point? Anybody? What is this point? Anybody? Anybody? 1.41 na. Simple logic, guys. This 60 degrees kada ya. This length is not tan theta. Just now only I told. Tan 60 equal to, consider this is y. Y by x is 0.66. Then find y. What is y? Tell. Tan 60 root 3. Root 3 into 0.6. 1.14. So y is 1.14. That means this is plus j 1.14. For intersection point root 2. Root 2 means what? Plus j 1.414 na. Root 2 is 414 na. Yes or no? So that means above you will get it. So intersection point is above here. Plus j root 2 and k equal to 4. Here minus j root 2. Minus j root 2 and k equal to 4. Minus j root 2, k equal to 4. So now draw the diagram. Draw the root locus diagram. This pole, it cannot leave the real axis. It cannot move to right. And it cannot leave real axis also, because only one pole. There is no break point. Simply it will go on, moves to the left. It occupies the 0. When k equal to what? Infinity. One pole completed. Next is this pole. This pole what happened? It leaves plus minus 45 and intersect at what? Minus j. Intersect at what? Come on. Intersect at plus j root 2 and near touch dot, parallel touch dot occupies the 0. It departs with minus 45, passes through plus j root 2 and occupies the 0. Occupies the 0. This is also same. Depart minus j 45, pass through j root 2 and near and occupies the 0. Like this. Occupies the 0. That means what happened? Tell. all the poles reaches all the zeros and the root locus diagram is what? Symmetrical about real axis. Okay, na? This is the RLA. Right. When it is stable, anybody? What is the range of K value for stability? Anybody? What is the range of K value for stability? Anybody? What is the range of K value for stability? 0 to 4. See here, K is 0 here. So K 0 means not stable. K slightly increase left. This goes to left. No need to think of this pole. But these two poles are moving right. We need to think of this. When moving right, where it is coming to imaginary? It is moving right. It is coming to imaginary. K equal to 4. K equal to 4 coming to imaginary. That means K greater than 0, less than 4. The closed loop system stable. K equal to 4. Poles comes to imaginary. Closed loop system marginal stable. When it is marginal stable, what is the frequency of oscillations? √2 radians per second. √2 radians per second. Is it clear, all of you? Any doubt? Ask it, man. Is it clear? With RH criteria, we got K kada ya? Akash, right hand. Tell, are you listening? Tell, man, what is your doubt? Tell.
Sir, can you repeat how K is equal to 4 parts?
Then, what is K here?
Where, sir?
Here, see the pen pointed. What is K here?
Okay. K is equal to 0, sir.
Then here 0, here 0. This going to left. No need to consider this.
Yes, sir.
Branches which moving right, you have to consider. What is K here?
Where, sir? Okay.
What is K here?
That's
That is
not.
K marginal, na? K is called K marginal with the imaginary axis.
Okay, okay.
What is K here?
K is equal to 4, sir.
0 to 4, left side means 0 to 4 stable.
Okay, okay. Okay, sir.
Right. Right. 0 to 4 stable. Equal to 4 and exactly it come to imaginary. When it come to imaginary, marginal stable. So frequency here, intersection point gives the frequency of oscillation. So frequency is √2 radians per second. Any more doubt? Divya, what is your doubt? Right hand, jaldi, jaldi. Right hand, jaldi. Tell what is your doubt?
Sir, in the left at infinity, K should be infinity.
Insignificant pole after some time.
Right.
Can you consider insignificant?
Yes.
You don't consider, na?
Okay, okay.
You have to consider the only dominant branches. Dominant branches means the branches which moves to right. That only we have to consider.
Okay, sir. Okay.
Right. Any more?
Sir,
Tell jaldi.
sir, actually, when we calculate the break-in and breakout points, sir,
Already we calculated, na?
that is centroid, na, sir?
Break points calculated, kada? Are you listening? This is break point only, na? First what I calculated.
Okay.
Invalid break point.
But this is invalid, na, sir?
Invalid,
Yes, sir.
What is the doubt?
Sir, actually, when we calculate that break-in, breakout and centroid point, that is confusing, sir.
You have to calculate for all the problems.
Okay, all the problems, sir.
Without calculating, how can you represent
Even though the imaginary
When the
points
number
are
of
not.
poles equal to number of zeros, we don't require the what? Angle of asymptotes and centroid. N0 means not required. Break points you have to calculate it by default.
And the centroid?
Centroid I told already. When you have to calculate centroid, when the number of asymptotes more than or equal to 2.
Okay, sir.
I told, man, you write all the points in the book. You read once or twice, okay? This Sunday I'll take morning to night like this means because lot of time is getting wasted. I have more. You should listen carefully. Now that fellow is asking to complete syllabus by 31st. I have to complete syllabus by 31st means I have to take the more time on Sunday. Coming Sunday or any holidays or no more holidays. Holidays are not there, I think. So next Sunday I have to take the more time. Right. Now come on, next point the natures of the system. Next point the natures, come on. One problem you are taking more than half an hour. Come on, what are the different natures it is having? The remain problems I don't discuss any more natures, you have to do by yourself. Come on, tell the natures. So whenever is it having overdamped, anybody? There is no overdamped because overdamped means minimum 2 poles required. Only one pole on the negative real axis. That also become insignificant after some time. So that's why the pole which is moving left we don't consider. Because after some time it will become insignificant. Here directly the poles are complex conjugate, means directly underdamped. This total range for underdamped only because complex conjugate. This total range for underdamped only. Underdamped system because complex conjugate means underdamped. Complex conjugate means underdamped system. Underdamped system. Underdamped system. When poles meet at a particular point here, what is the nature here? Anybody? What is the nature at this point? Tell. At this point, what is the nature? Undamped nature. At this point, undamped. Undamped nature. Undamped system. So it is called undamped system. Poles comes imaginary undamped system. Undamped system. This is underdamped system. Complex conjugate, here complex conjugate, here complex conjugate, here complex conjugate, underdamped. Now tell what is the range of K value for underdamped? Anybody? Range of K value for underdamped? Anybody? Underdamped range of K, come on. What is the answer? Anybody? 0 to 4. Yes or no? 0 to 4. So here 0. But 0 means here pole is there, it should not consider. That's why greater than 0. Greater means it will be left. This is also left. So that means K greater than 0, less than 4. The system is underdamped. The system is underdamped. K equal to 4, the system become undamped. K equal to 4, undamped. What is the natural frequency? Tell. Omega n equal to what? Root 2 radians per second. That's all. Next problem. Is it clear, all of you? Any more doubts? Clear, all of you? Jaldi. Right. Listen carefully so that you can utilize the maximum time for subject. Same thing repeating means it is wasting time now. That's why. Listen carefully. Make a notes also. At least if you write once now, it will store in the mind. Try to make the notes. Write the notes. Okay, next problem. This problem homework only. I hope you will do. Homework. Draw root locus. Compulsory agenda. Draw RLD to the given system. This one if you do by yourself now, you will get the confidence. G of S, H of S equal to Ks by S square plus 4. Draw the root locus. Ks by S square plus 4. Second bit. Find the range of K value for stability. Find the range of K. Range of K for closed loop stability. Third bit. Identify the different natures. Identify the different natures of the system. Different natures of the system. And its K values. And K values. You can do na? Simple problem given. You will do na? Priya, what is the doubt? What is critical damped? Where is critical damped? Critical damped means 2 poles required. Is there anywhere 2 poles? Is there anywhere 2 poles? Then how can I say critical damped? Critical damped means 2 poles will meet on the real axis. No critical damped. Okay? Is it clear? Right. So do homework this. Next problem. Draw root locus. K by S power 4 minus 1. Come on, do it. Today date 22nd. Oh, 8 days, 9 days. Now come on, do it all of you. Sai Krishna, any doubt? Right. Come on, do it, man. Look at the poles. It can be written as what? K by. This is like S power 4. A square minus B square form, na? Like S square whole square minus 1 square whole square. The A square minus B square. A square minus B square can be written as what? Tell. A square minus B square can be written as A plus B into A minus B. That means S square plus 1. S square minus 1. Come on, represent the poles and zeros in this plane. We remember centroid required only when the angle of asymptotes more than or equal to 2. Complex poles are there, then only angle of departures and arrival. Otherwise not required. For each and every problem required to calculate breakpoints, especially breakpoints and any more mainly breakpoint. Almost for all the problems you require to calculate. Come on, do it. Represent the poles, huh? Come on. Where are the poles? Tell. One pole at plus J1. Another pole at minus J1. One pole at minus 1. One pole at plus 1. Here there exists a root locus branch. This is RJ. Now find the break point. First find the break point. So d by ds of 1 by s power 4 minus 1 equal to 0. 0 minus 1 into v dash into 4s cube equal to 0. So break point how much? S equal to 0, which is valid break point. Because here break point is 0 valid. Next command find it. Next what? Angle of asymptotes. Number of asymptotes. Number of asymptotes. N equal to P minus Z. 4 minus 0 becomes 4. Angle of asymptotes. Theta command. When poles equal to 0, no need to calculate. N is 0 means no angle of asymptotes, no centroid. Break point for each and every problem you have to calculate. Multiple poles more than or equal to 2 poles is there means you need to calculate break points. Angle of asymptotes tell 180 by 4. P minus Z 4, 45 degrees. Multiply with 3. Follow, into 3 means what? 135 degrees. Into 5 means 225 degrees. Into 7 means 350 degrees. Into 1, into 3, into 5, into 7. Centroid. Sum of real part of pole. One real part is plus 1. Another real part minus 1. No more zeros. Divided by 4. Centroid is 0. Any more what you have to calculate? Angle of departure calculate. Angle of departure calculate. Come on, all of you calculate angle of departure. Calculate angle of departure, all of you. Angle of GS of S. At S equal to what is the complex pole tell? Plus J1. Plus J1. Equal to what tell? Angle of K divided by angle of S plus 1 for left hand side pole. Angle of S minus 1 right hand side pole. Angle of plus J1 for imaginary negative. Angle of S minus J1 for imaginary positive. Replace S by plus J1 for tell the angle of departure. Come on, calculate. So what we are getting? Angle of K by angle of what? 1 plus J1. S J1 na substitute. Angle of minus 1 plus J1. Angle of J1 plus J1. Angle of J1 minus J1. So what happened? Tell this cancel. And now tell the answer. Angle of K. Angle of 1 plus J1. Angle of minus 1 plus J1. Angle of J2. Angle of 0. Come on, what is the answer? Angle of K 0. Angle of minus 1. Angle of 1 plus J1 45 degrees. Angle of minus 1 plus J1 is what? 180 minus tan inverse na? Already I told once. It is what? 135 degrees. This is 135 degrees. 180 minus tan inverse imaginary part by real part means 1 by 1. It is 135 degrees. Plus J2 is 90. Plus 0. You solve this, you will get minus 270. Then angle of departure equal to 180 plus angle GH. 180 minus 270. That equal to minus 90. So pi d equal to minus r plus 90 degrees. Pi d is minus r plus 90 degrees. Right. Now draw the diagram. Now draw the root locus diagram. Draw the root locus diagram. No problem. Right, represent the poles. Plus J1. Points will get together. Right. Okay. This is j omega plus j1, one more pole minus j1, one more pole plus 1, one pole minus 1. Here there exists a root locus branch. Then breakpoint 0, centroid 0, angle of asymptotes 4. One is 45 degrees, another one 135 degrees, another pole 225 degrees, another pole 315 degrees. Now 4 poles, 4 asymptotes. Angle of departure already we calculated. This is minus 90 like this. This is plus 90 like this. Now draw the diagram. As k increases, this pole will depart with minus 90. This pole depart with plus 90. This pole depart with 0 degrees. This is 0 degrees. This pole depart with 180. This is 180 degrees. All the poles move in equal in opposite direction. So whenever all are having equal distance from the centroid, from the centroid, check in distance from the poles. From the centroid, one check the distance. This is the centroid. Here to this pole, what is the distance? 1 unit. Here to this pole, what is the distance? 1 unit. Here to this pole, what is the distance? 1 unit. Here to pole, the distance 1 unit. All are having equal distance. All are having equal distance from the centroid. Then all the 4 poles move in equal in opposite direction. All the 4 poles move in equal in opposite direction. Then all the 4 poles meet at the breakpoint. Then all the 4 poles meet at the breakpoint. All the 4 poles meet at the breakpoint. How many poles meet at the breakpoint? All the poles meet at the breakpoint. Already poles are imaginary, no need intersection point. Come on, tell how many poles meet at the breakpoint? 4 poles meet at the breakpoint here. There are 4 poles meet at the breakpoint. ठीक है ना? Whenever especially breakpoint equal to centroid. Whenever breakpoint equal to centroid and all the poles are having equal distance. All the poles are having equal distance from centroid. Then all the poles meet at the breakpoint. All the poles meet at breakpoint. How many poles meet at breakpoint here? Tell. Then all the poles meet at breakpoint. How many poles meet at breakpoint? Tell. 4 poles. So in the above diagram, 4 poles meet at the breakpoint. In the above diagram, 4 poles meet at breakpoint. 4 poles meet at breakpoint. 4 poles meet at breakpoint. What is the k value at breakpoint? Tell. K value at breakpoint. What is the k value at breakpoint? Anybody? What is the k value at the breakpoint? Anybody? 1 Maya. 1 only. See here. K. Product of length here to here 1 unit. 1 unit. That means K is nothing but 1 into 1 into 1 into 1. No zeros, no 1. So 1. So here K value is 1. So the K value at the breakpoint is K equal to 1 into 1 into 1 into 1 divided by 1. So it will become 1. K value at breakpoint equal to 1. Sometimes they are asking closed loop transfer function at the breakpoint is. Come on, tell what is the answer? Closed loop transfer function at the breakpoint. Closed loop transfer function at breakpoint is. Come on, what is the closed loop transfer function at breakpoint? Anybody? Assume unity feedback, either mentioned or not mentioned. Assume h of s is 1. Either mentioned or not mentioned, always assume h of s equal to 1, because then only we can write closed loop transfer function. Come on, anybody answer? Anybody can you answer this question? 1 by s power 4. Very good. See what is g of s becomes tell? G of s become k by s power 4 minus 1. K we got 1. So 1 by s power 4 minus 1. Assume unity feedback. H of s1. What is the closed loop transfer function tell? Add the numerator term in the denominator. Just add it. Plus 1 cancel. So what is the answer? 1 by s power 4 is the answer. Or we know that when k equal to 1, 4 poles at origin. When there are 4 poles at origin, what is the transfer function? 1 by s power 4. When there is 4 poles at origin, means transfer function 1 by s power 4. Yes or no? Is it clear, all of you? Is it clear, all of you? Right. Next. So then, after meeting 4 poles, what happened? Tell all the 4 poles. The 4 poles meet here means it leave with what? Plus or minus 180 by 4 means 45 degrees. One pole directly enter into the asymptote with the angle of plus 45. Another pole directly enter into other asymptote with the angle of minus 45. So plus 45 minus 40 is angle 90. Plus 45 to minus 45, 90. Add 90 here. 45 plus 90. 45 plus 90 means what? Below 135. Again add 90. 225. All the 4 poles leave from the point by maintaining equal phases. Then directly it enter into the what? Asymptote and occupies the 0. It enter into the asymptote and occupies the what? 0. This is also enter into asymptote, occupies the what? 0. Occupies the 0. Enter into asymptote, occupies the what? 0. Okay, now all the 4 poles reaches the zeros. Is it clear, all of you? Is it clear, all of you? Is it stable, anybody? Is it stable or unstable? Is it stable or unstable? Yeah? Always one pole in the right. Always one pole in the right, unstable. Even comes imaginary, 4 poles unstable. Again turning right, unstable. That means for all the values of k, for all the values of k, k unstable. For all the values of k unstable. For all the values of k, system unstable. Unstable means there is no more natures. Unstable means we don't discuss any nature. Natures for only stable systems. Okay? Is it clear, all of you? Right, next problem. Right. Actually, this is to get the idea and breakpoints, otherwise not required. Next problems almost to get the idea. One more point I forget to tell here. Listen. Whenever breakpoint equal to centroid, here what is the breakpoint? 0. What is the centroid? Tell 0. Here breakpoint 0, centroid 0. That equal to real part of complex pole. What is the real part of complex pole? Tell 0. Yes or no? Breakpoint 0, centroid 0. The real part for the complex pole is 0. Whenever all these 3 are same, no need to calculate angle of departure. Blindly we can write minus or plus 90. This statement also you should remember. This is very important. This you have to remember because for objective typing they are asking whenever breakpoint. Simply they'll give a problem. They'll ask how many poles meet at the breakpoint. You should check the what? Is it breakpoint equal to centroid or not? You have to check. After that, what you have to check? The distance you have to check. If all are having equal distance, all is going to be meet. All are going to be meet. Be remember. One more point you have to remember is. One more point you have to remember is whenever breakpoint equal to centroid, that equal to real part of complex pole. Then the angle of departure is phi d equal to minus or plus 90. It is valid for all the problems. Any numerical you take, breakpoint equal to centroid, that equal to real part of complex pole. Breakpoint equal to centroid, that equal to real part of complex pole. Don't calculate angle of departure. Directly write minus or plus 90. Check it here. Breakpoint 0, centroid 0, real part of complex 0. All are 0 means don't calculate. Simply minus or plus 90. Is it clear, all of you? Clear? Right. Next problem. Again, this concept will come in the next class. You should not forget this. I'll write angle of departure directly. I'll write this statement. I'll write angle of departure. So read today itself all these points. Don't be lazy. Draw the root locus. Time అయిపోయా. Come on, yes into. Come on, do it, man. Come on, represent the poles. Find the breakpoint, jaldi jaldi. Find the breakpoint, sir. Here there exists a root locus branch here. Because here 2 poles, here also there exists a root locus branch. Next, find a breakpoint. Find breakpoints. At origin, no breakpoint, one pole only. Now breakpoint means minimum 2 poles should meet, or 2 poles should locate at one point. Then only breakpoint. Come on, tell. Breakpoint and nobody telling. 1 by expand this. What is expansion? S power 4 plus. Like this problems, it is not possible to calculate without calculator. That's why in the exam they don't ask, you don't need to worry. See, either you observed or not, last 3-4 years onwards you observed question. They are not asking more than third order system. Maximum third order. So differentiation becomes the what? Second order. So that you can find the roots. They don't ask like this higher order system. But why I discuss means in case by mistake ask also. How to get it answer means from the options you have to get the answer. For example, listen here, S power 4 expansion, how much you are getting? S power 4 plus 4s cube plus 5s square plus 2s. Is it correct, all of you? Expansion correct, na? One breakpoint by looking itself you can tell, that is minus 1. One breakpoint by looking itself you can tell minus 1. Now u by v from breakpoint to tell 0, minus 1 into 4s cube plus 12s square plus 10s plus 2 equal to 0. So that means 4s cube plus 12s square plus 10s plus 2 equal to 0. See, then you have to find the roots. Then what you listen, all of you listen. All of you listen, bhaiya. Like this questions given, if you ask the breakpoint, then calculator required. But we don't have calculator. Then how to select the answer means go from option to question. Option to question. Option to question. Option to dk by ds. So you observe option. Select from option. Select from option. How to select means the valid breakpoint is the one. The valid breakpoint is the one. It must be on root locus branch. It must be on root locus branch. Root locus branch for which dk by ds should be 0. For which dk by ds should be equal to 0. Okay, now. So for example, I will give the options. Option A minus 0.5. Option B minus 1. Option C minus 1.5. Option D minus 3. That means what are the options here, correct or wrong? For example, here also I will take minus 2.5. For example. So which are wrong? Directly I can say that minus 2, minus 3, not on root locus, and these two wrong. So in this 2 only. So both are on root locus branch, which is correct means is up to tier minus 0.5. S equal to minus 0.5 up to tier. And check it, if it is 0, it is correct. So it's up to it is wrong only. I already verified. Minus 1 is up to, come on, tell, check it. Check for minus 1. Because minus 1 directly we can identify repeated poles. Na? Check for minus 1. Come on, 4 into minus 1 whole cube plus 12 into minus 1 whole square. It should be 0, then it is valid. 10 into minus 1 plus 2 equal to 0. Come on, tell the answer. This is minus 4. This is plus 12. This is minus 10 plus 2. What is the answer? 10. It should be 0. If it is 0, then it is valid. Is it 0 or not? 0. That means what? Minus 1 is the correct answer. So like this. And if the valid breakpoint is the one, it should have on root locus branch and for which dk by d 0. Sorry, whatever it is, you find the roots for this, you'll get 3 breakpoints here. Come on, find the roots. Come on, man. What you got? 4s cube plus 12s square plus 10s plus 2 equal to 0. What are the roots, man? Anybody? What are the roots? We'll get 3 breakpoints that are, one is minus 1, correct, minus 0.29, minus 1, minus 1.71 you will get. Check it. 3 breakpoints you will get. So like this, 3 breakpoints. All these 3 valid only. All are valid because all are on root locus branch. Check it. Minus here, minus 0.25. This is valid. Here minus 0.25 valid. Minus 0.29. Minus 0.229 valid. Minus 1 valid. Minus 1.71 also valid. All are valid only. All are valid. That's all. Next, number of asymptotes. 4. Angle of asymptotes. 45, 135, 225, 315 degrees. Next, centroid you calculate. Minus 1, minus 2, minus 1, minus 1. Yes or no? Minus 2, minus 1, minus 1. So divided by 4. So that is minus 1. Now draw the diagram. All of you draw the diagram. The range of k values that and all find by yourself by using RH criteria in your home. One pole at origin. Here mainly why I am discussing mean to find breakpoints, to give idea on breakpoints. So here root locus. Here root locus. Centroid minus 1. One of the breakpoint also minus 1. 4 asymptotes are. One is 45. (135). The multiple poles, multiple zero locations by default one of the breakpoint. Be remember. The multiple pole location, multiple zero locations. Here minus 1 by default breakpoint. Minus 1 here by default breakpoint. No need to calculate. Whenever repeated poles, repeated zero locations are there, that is by default breakpoint. Now what happened? Listen here. Listen all of you. See here, 2 poles repeated at minus 1. 2 poles repeated. That is a by default one of the breakpoint. That is minus 1. Breakpoint means don't think that it should leave the real axis. Breakpoint means don't think that it should leave the real axis. Moving away or enter into the point is called breakpoint. As k increases, as the adjacently root locus branches we are having, one pole moves towards the right, one pole moves towards the left, because here adjacently root locus branch is there. Adjacently root locus branch is there. That's why one pole moves towards the right, one pole moves left. This is moving towards the left side. This pole moving towards the right side. Towards the right side. Okay, now? Then what happened then? So these two poles move in opposite direction. Then collide at minus 1.71. Leave with plus or minus 90. Near to asymptote, parallel to asymptote. Enter into asymptote and occupies the 0. Okay, na? So near to asymptote, parallel to asymptote, enter into asymptote and occupies the 0. I'll put the dots. That indicates it goes towards the 0. This is also same. Moves towards the origin. Put the dots. Okay, na? Again, this two pole also. Both move opposite. Collide. After collide, then near to asymptote, parallel to asymptote. Why I solved this problem means, be remember, the repeated pole location becomes the one of the breakpoint. The poles repeated minus 1. That minus 1 becomes the what? One of the breakpoint. Repeated poles location. Becomes one breakpoint. Becomes the breakpoint. Don't think that breakpoint means it should leave the real axis. It is no need to leave the real axis. Here 2 poles, it won't leave. One is moves left or right because root locus branches are there. If the root locus branches are not there, then we can say that if the root locus branches are not there, then we can say that it can leave the real axis. In case here adjacent no root locus branch, it can leave the real axis. Whenever multiple poles location like this will come, identification of nature is little bit difficult, but here we can identify because it is symmetry. K0 means pole at origin, don't say critical damped. You should not say because it is a marginal stable system just like. So that means K go on here critical damped, here also critical damped. So in this two case, because here find K, both are same. You find K value here, you find K value here, both are same. For objective type it is not required, conventional will practice all that. So here to here under damped, here undamped, here critical damped, here over damped, like that. So not required all that because it is higher order system, it is not required. Mainly get the idea on breakpoints. Okay? Right. Mahalakshmi not critical down because pole at origin is there. Next, one more last problem. 2 minutes. So that this conclusion will complete. I'll do some problems homework. You do it. RLD. Zapper gender. K into S plus 1 whole square by S into S plus 2. Jaldi. Why I am solving this problem means no asymptotes, nothing, no centroid, no angle of departure, nothing. Because number of poles equal to number of zeros. 2 poles, 1 pole at origin, 1 pole at minus 2, and 2 zeros at minus 1. Why I am solving this problem? Anybody can you guess it? Anybody can you guess why we are solving this problem? Anybody can you guess it? Because there is one breakpoint you find in your O. The breakpoint is minus 1. How can you say means if it is a repeated zero location? Here root locus branch exists. Here root locus branch exists. As K increases, both the pole move opposite direction, both the pole occupy zero. It is like just like breaking point. 2 poles meeting at K equal to infinity. 100% it is a breakpoint minus 1. You check dk by ds and then you tell the answer tomorrow. So it is 100% it is a breakpoint. That means multiple repeated zero location also act as a breakpoint. Repeated zero location. Repeated pole as well as repeated zero location. Repeated zero location becomes breakpoint. So be remember. At any location, poles and zeros are repeated means that location by default it will become a what? Breakpoint. Is it clear? Homework is the cheyandi. Compulsory at least breakpoints kanukondi. Find breakpoints and angle of departures. Tomorrow I'll draw the diagram. Tomorrow I don't calculate anything else. Just I'll draw the diagram. You calculate all the points. At least breakpoint angle of departures you calculate. Remaining things you can calculate in the mind. Okay, na? Use the calculator. Without calculator, actually we don't require this. Actually, whatever we studied, it is more than sufficient actually. So, but still, we'll practice. These problems are very, very important for IES conventional. In this concept, we'll get about complex breakpoints. That's why I have to discuss. Roughly, I'll discuss this to find out all the factors. Breakpoints, angle of departures, confound. You find the two angle of departures and breakpoint, so that I can draw the diagram quickly. Tomorrow I'll try to close this chapter. Okay? For these 6 problems you find breakpoints and angle of departures. Okay? So that tomorrow I can solve the problems quickly. I'll try to close this chapter by tomorrow. Okay? If you have any doubt you can raise hand. If you have any doubt, you can raise the hand, man. Any doubt? You ask now doubts not in the middle of the class, man. You ask if you write the doubts in a paper, ask at the end better, so that I can spend whatever the time I want it. Akash, any doubt? Sharad Chandra, Dhruva, Mahalakshmi, any doubts? Raise the hand. No doubt, sir. Can I close it now? Akash, any doubt? Are you?
No, sir. No, sir.
Right. Right, I'll close it, man. But compulsory solve these 6 questions. Actually, objectives not important, no doubt. But IES conventional always they used to ask. This is a one special case I have. In root locus, this is a one special case problems. These are. Okay, thank you.